Hello, everybody. This is Sunday, September 4th, and we are heading into Module 2 of our online astronomy class. Hope you're all doing well. Hope you're having a good Labor Day weekend. Now, if you are following the Artemis program that is going to send a test flight, launch a rocket around the moon, and then put it in orbit around the moon, and then come back to Earth, that launch was supposed to be on Saturday, but it's been scrubbed. And they had a leak in the hydrogen fuel tanks, liquid hydrogen tanks. And so that is at least going to be launched 2 weeks from now or more. So at least 2 weeks away. But it's a slow process. It's important to get it right. And I'm sure sooner or later it'll get up there. And if the flight is successful, next time there will be a crew of people aboard, and that'll be exciting. So here we are, Module 2. Module 2 tells us a little bit about the history of astronomy, how we came to understand the universe, and what our first halting steps were. And those first steps, as we'll find out, were not always successful. You know, in science, what we do is that we make models of the way the universe operates. And a model is just a coherent description that describes how all the parts that are involved relate to each other and how they interact to produce motions. So we make models, and some of those models correspond to reality, and some of them don't. And those that don't are cast aside, and the successful models go on. So we're going to learn about a model today that, although it was actually very successful, turned out to be completely wrong. But let's start. We don't know, in fact, when I say let's start at the beginning, I don't know where the beginning of astronomy was, because I imagine the first people to ever look up at the starry skies like you see behind me and wonder about what was up there and why the patterns changed from season to season. You know, those were very, very early people, and probably left no written records. We know the Egyptians, the Babylonians, Sumerians, very early people, people in the Indus Valley civilization, all studied the star. But we're going to start with ancient Greece. And we're going to talk about how the ancient Greeks looked up at the sky and what recorded what they saw. And, you know, they knew something about our solar system and about our planet. They knew how big Earth was. And they knew how big the moon was and how far away the moon was. They learned how big Earth was just by looking at how the direction of sunlight changed as you moved north and south on the Earth's surface. And they knew how big the moon was just by looking at the curved shadow of Earth on the lunar surface when the moon moved into Earth's shadow during a lunar eclipse. So they knew some things about our planet, but they didn't know how far away the sun was. They didn't know how far away the stars were. They didn't know what stars were. And so they made models. Now, they knew that stars would rise in the east and set in the west. And remember, here as you look at these background stars behind me, it's as though you were standing like I was on the shore of Summit Lake, and you are looking south. And remember, if you are looking south, then over this way, if you hold out your, if you point to the left, then you are pointing to the east. And so the east is to the left side of your screen. And if you're pointing west, then you're pointing to the right side of the screen. So east is to the left, west is to the right. And they would watch, as I said, the stars would rise in the east and they would set in the west. And they thought that there was a huge sphere of stars that was rotating around the Earth, and the Earth itself didn't move. And they thought that everything moved in circles at a constant speed. This was called uniform circular motion. And they believed this because, well, circles in their mind was the perfect shape. And the heavens were perfect. And so circular motion had to describe the heavens. Things moved in a circle at a constant speed. And, this made sense for the stars. The stars would rise in the east, move at a constant speed, and set in the west. That made sense because this celestial sphere of stars, this great sphere that held the stars with Earth at the center of the sphere, that celestial sphere was rotating around Earth once every day, carrying the stars with it, in their mind. But one thing they couldn't figure out were the planets. And in this picture that I took, there are two planets. And one is right here, and that is Mars. And then Saturn is over here. And they would look at how the planets moved against the distant background stars. So from night to night, a planet, and I'll take Mars as an example. So here's Mars. And then normally from night to night, would move a little bit west, a little bit eastward through the stars. From night to night, would move a little bit eastward, 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 and so on, from night to night. And so as the days passed, the planet Mars and all the planets would move from west to east across the sky through the stars. But, and this is what drove them crazy, sometimes, and this happens for all the planets, a planet here is moving eastward from night to night to night to night to night to night. But then sometimes it would slow down and actually move backwards, westward. And they called that retrograde motion. And then it would stop and it would move eastward again. So what would cause the strange motion of Mars and Saturn? What would cause them to move generally eastward, but sometimes it would back up over a number of nights, go backwards, westward in retrograde motion, and then move eastward again. It happens all the time. It's a regular occurrence for the planets, for all of the planets. And in fact, they got used to it and they called planets wanderers. And in fact, the Greek word planet means wanderer because the planets would wander through the skies. What in the world could cause this? And remember, you just can't say, well, the planet out there backed up and went forward again, because all motion had to be circular. So let's take a look at this. This is happening right now in our sky. So I'm going to pull up Stellarium and show it to you. So let's pull up Stellarium. Here it is. And I've moved up to October 20th. And as you can see, Saturn is right at the center of your screen. We're looking south, just as we're doing in this photo that's behind me. And over here on the left is east, and over here on the west, over here on the right is west. So first of all, I'm going to click on Saturn. And then I'm going to freeze Saturn or focus on Saturn at the center of our screen. Now I'm zooming in on Saturn. And you can see over here, there's a star called Nashira. And over here, there's a star called I Capricornus or I Cap. It's in the constellation of Capricorn. And here's Saturn. I'm going to advance the days one by one. Right now, you can see that the Saturn is closer to the I Cap than it is to Nashira. But watch what happens as I advance the days one at a time. You can see that Saturn is going to move. And it's getting farther from the I Cap star and closer to Nashira. That means that Saturn is moving generally eastward through the stars because it's moved generally in this direction to the east. Now, that's not always the case. I'm going to change things up here. So I'm going to go to today's date. So let's go to today. It is the 5th. I'm sorry, the 4th. There we go. There's the 4th. And it's earlier in the summer, so I'm going to have to go a little bit later in the day. But again, here is Saturn. And let's zoom in on it. Now remember, normally Saturn is going to move through these stars to the east. Let's see what happens now as I go one day at a time. It's going in the opposite direction. Can you see these stars going past it? The star just moved past Saturn. That means that Saturn is moving against the star to the west. So Saturn right now is in retrograde motion. Let's keep going. You can see Saturn is moving still to the west, but now it's stopping. And now it's going to move east again through the stars. And now Saturn is set. It's late enough that Saturn has actually set. So let me back up a day there, a couple days. So Saturn right now is in retrograde motion. And near the middle of November, it will stop, change directions, and head east again. So this happens with all of the planets. But what causes it? The Greeks didn't know. I'm just going back to today's sky. There we go. And we'll take a look at today's, this week's sky a little bit later. I'll come back to it. Well, how can you make a planet move in one direction and then change directions and keep on going using only circles, only circular motion? Well, that's hard. So here's the problem, just to make sure. Here, this little marble represents a planet. I'm going to hold it over here. And you can see this planet normally moves very slowly against the distant background stars there. That's moving to the east, which is what it normally does. And that's moving in a big circle around the Earth, which is at the center of all things. And so that counts. That works just fine. But how do I get it from back up using just a circle? Now, what I have here, and this is going to be hard to show you because it's green and I'm using a green screen behind me. And so part of it is going to appear to be invisible. So it's sort of funny. Here, maybe if I hold it close, you can see that it is green. But that's okay, because what I have here is a little turntable that turns. Now I'm going to put the planet on that turntable. And then I'm going to hold the planet over here and move it slowly across the sky. And as I do that, you can watch as the planet slowly changes direction as it moves around the sky. So I'm going to move this toy here in a straight line at a constant speed, but this turntable is going to turn the marble in a circle. So let's see what that looks like. And we're going to see which direction the marble moves against the distant background stars. So I have to wind it up. Now the marble's only going to be going in a circle. That's fine. This small circle that the marble's moving around is going around in a bigger circle. That's just fine. It's circular motion. But watch what the total outcome is. I'll just wind that up a little bit more. I'm going to hold it over here and then slowly let it go across the sky. So here we go. Tilt it towards you a little bit so you can see it. Now let's watch how it moves through the sky. So there it is. Now it's moving backwards. Can you see? Now it's moving forward. Now it's moving backwards. Now it's moving forward to the stars. And now it's moving backwards to the stars. And now it's moving forward to the stars. Ptolemy is the one who really perfected this whole system of how the planets moved. He lived about a couple hundred years AD, fairly late in the game, as far as the Greeks goes. But his system lasted for about 1,500 years until around 1600. And it had the planet moving in a small circle, just like the turntable there. The planet moves around in a small circle, and the center of the small circle moves in a larger circle around Earth. So here it goes. The center of the small circle moves around a large circle. The small circle is called an epicycle. The large circle is called a deferent. And so Ptolemy's system of epicycles and deferents worked really well for predicting the positions of the planets against the stars. Hugely successful. And as I said, it lasted for something like 1,500 years. Each planet had to have its own epicycle, its own deferent. Things got very, very complicated, to really describe all of the planets out there accurately, all the planets they knew about anyway. That took as many as 56 circles. But it worked, and that's what people used. It worked until a Polish lawyer started really looking at things. He was a Polish lawyer. He was a mathematician. He was a physician. He was a lot of things. And back in those days, his name was Nikolai Kopernik. But back in those days, you would write all of your results up, your papers in Latin, and you gave yourself a Latin name. And so his name was Copernicus. Copernicus said, no, this system is just too complicated. And it works a lot better if you put the sun at the center of the solar system and have all the planets move around just the sun. Now, this was heresy, right? This was serious heresy because, the dogma was that the Earth does not move. Everything moves around the Earth. The Earth is the center of creation. But Copernicus said, no. It's really all the planets that are orbiting around the sun. Now, Copernicus got it half right, because he still had the planets orbit in circles. The person who corrected that and who finally described how planets move around the sun was Johannes Kepler. And Kepler wrote his, he tried all sorts of shapes. This is his book. It's Astronomia Nova, and it's filled here. I don't know if you can see, but it's filled with diagrams that he tried for different shapes. He tried all sorts of things, and he almost could use circles, but he was using Mars, orbits of Mars, the observations of the orbits of Mars, and he tried to fit those to a circle. And these observations were taken by Tycho Brahe, who was the last of the great naked eye astronomers. The telescope had not been invented yet. This is in the late 1500s, early 1600s. And Tycho made exquisitely accurate observations of the planets night after night. And Kepler inherited his observations. And Kepler worked in Prague. And I took a trip to Prague, and they had a science museum there. And this was some time ago. And Kepler's sighting instrument that he used to measure the positions of the planets, because Kepler himself did some observations, it was just out there, and you could, look through the eyepiece and look just like Kepler would have at the stars and planets. Today, those are behind glass cases and you can't get near them, but this was a while ago. And it was just a thrill to be able to, I couldn't use them to see the stars because they were inside, but it was still a thrill to see Kepler's instruments. But Kepler tried to fit Mars to a circular orbit, and so close, within, he was only 8 minutes of arc off. That's 8/60ths of a degree. And he threw out circles because he had such respect for Tycho Brahe's observations. And finally, Kepler figured out that the correct shape of orbits were not circles, but ellipses. An ellipse is sort of like an oval. You can read about that in your book. And Kepler came up with 3 laws that are correct, describing how planets move and where the sun is, and how the planets move in relation to the sun, and how fast different planets go around the sun. Now, we still didn't know the distance to the planets, and so we scaled everything to the average distance between the sun and the Earth. And the average distance from the sun to the Earth is called an astronomical unit. And so we could say that Mars is 1.5 astronomical units from the sun. It's 1.5 times further from the sun than Earth is. We could say that Venus is 0.72 astronomical units from the sun, because Venus is closer. It's 72% as far from the sun as Earth is. So they still had scale models, but the important thing is that the scale models predicted the positions of the planets just as accurately as Ptolemy's did. It was much simpler, and it explained retrograde motion. Retrograde motion, if both Earth and, say, Mars are circling the sun, Earth is going around the sun faster. And if you've ever had the experience, and I'm sure you have, you just are maybe running around a track, walking around a track, or even driving a car, you know that as you pass a more slowly moving car, that car appears to be moving backwards as you pass it. And that's what's going on right now. Earth is passing Saturn. And so Saturn appears to be moving backwards against the stars. Saturn, the direction of Saturn's motion hasn't changed. The planet's motion is still forward in its orbit. But because we're passing it, because we're going faster, we see Saturn, as we pass it, appear to move backwards. And that explains retrograde motion. Retrograde motion is a hard thing to visualize and understand. There's a couple of videos in this module, so I hope you'll watch those videos. But Kepler, and nobody at the time, understood why his laws worked. He knew he had described the heavens, but he didn't know why those descriptions were as they were. The last person you'll learn about in this module is Galileo. Galileo didn't invent the telescope, but he perfected one. And that was around in the very early 1600s. And he turned his telescope, his crude telescope, toward the planet Jupiter. And he saw 4 moons moving around Jupiter. And that proved that Earth was not the center of all things in the solar system, because here's 4 moons moving around Jupiter. He also looked at Saturn over here, and he discovered the rings around Saturn. Now, he said that Saturn appears to have ears because his optics weren't as good as modern optics, and so he saw these ears on either side of the planet. But still, it was Galileo who really proved that we don't live in a geocentric solar system. Ptolemy's solar system was geocentric, Earth-centered. We live in a heliocentric solar system, sun-centered. And Galileo, as much as anybody, really established that. So, I hope you enjoy learning about this early history of astronomy. It is really fascinating. And next time, we'll learn about Newton and Newton's laws of motion and gravitation, because Newton explained why Kepler's laws work. So before I go, let's take one more look at stellarium. So I'll do that. I'll pull it up. So let me share the screen here. I'll share the screen and go to stellarium. There we go. And I just wanted to show you the moon tonight. There's the moon. There's Saturn, which is undergoing retrograde motion. You can see it for yourself. Take some binoculars out. See what stars are near Saturn tonight. Take a look tomorrow night. See what stars are near Saturn. You'll see that Saturn is moving to the east. Now, this is on the 5th. Let's go forward to the 10th. Right now, the moon is in the center of the Milky Way, so this is a terrible time to see the Milky Way. But the moon is moving from night to night, as you can see, to the east. The moon does not experience retrograde motion because the moon is actually orbiting Earth rather than the sun. And here you can see, I'll just pull the sky around a little bit and take us a little bit later at night. And there is the Milky Way right there. Now on the 10th, it's a full moon. And so next Saturday, it'll be the full moon. The 10th, it's the harvest moon. And the moon will be very close to Jupiter. That'll be sort of a cool sight to see. So I hope you enjoy learning about these ancient astronomers, some of the first astronomers who are part of the history we're studying. And we'll look forward to seeing you next time. Now, if you have any questions, you can always send me an email, put something in the discussions. You can be happy to set up a Zoom meeting, or we can meet in my office. And your first 2 modules will be due, the homework for those modules is due next Monday, not Monday the 5th, but Monday the 12th. I gave you 2 weeks for module 1 in order to let your textbooks have time to arrive. So, till next time, I hope you enjoy learning more about this, and I will see you next time. Bye-bye.